Awesome. Okay. Cool. So, Ella and Stella, here we go.
Hi, we are Stella Young,
and Eloise Bertrand.
and today we're going to do a presentation for our first immersive Assembling SF. We're presenting fossils.
We want to know what conditions foster the creation of fossils, as in, why don't the specimens just decompose? What exactly makes a fossil? First, it might be helpful to know what fossils are, so let's start off with an intro. Fossils are the remains or traces of ancient life or organisms that have been preserved by natural processes. Fossils are actually the rocks themselves instead of the remains. To fossilize, the remains need to undergo a specific process. First, the specimen dies, of course. The remains then either sink to the bottom of a body of water or are quickly buried in sediment and organic particles. With the help of natural phenomena like landslides, the remains are buried in even more sediment. Over the course of millions of years, sedimentary rock is formed and the remains are stuck within layers. Slowly but surely, the remains are turned into mineral matter, or in simpler terms, they turn into rocks.
Now that we know how fossils are made, where can we find them? The answer is that fossils are most commonly found in deserts, oceans, lakes, and sometimes marshes and swamps. Within those locations, you'll notice an outlier that we'll talk about later. They're usually buried underground in the crust of the earth, the thinnest and outermost layer. Fossils are found in sedimentary rocks.
As we said, when specimens die in an environment with organic particles, also known as sediment, they're buried over millions of years with more and more layers. These layers happen to form what we call sedimentary rocks, which are formed by the deposition of those sediments and minerals. Sedimentary rocks are one of 3 types of rocks, but we won't distract you with those.
There are 9 different categories of fossils, each with unique aspects. Mold fossils are created by a process called leaching, where the actual animal or plant is removed, leaving an imprint behind. Cast fossils are the result of the last one, when hollow gaps get filled with other minerals. True form fossils occur when the plant or animal itself gets trapped within ice, tar, or another substance and gets fossilized. Trace fossils are traces left behind by the organism. Think of big footprints. Body fossils are fossilized parts of organisms like shells, bones, and teeth. Fossilized species are feces that are preserved through petrification, which is very rare. Petrified fossils are formed when minerals from the underground replace certain or all parts of organisms. Carbon film fossils are when an organism dies and is deep within sediment, then a thick layer of carbon is transferred onto the rock and the organism itself breaks down over time. Finally, preserved remains are a form of fossilization in which some parts of the organism are preserved, hardly changing at all. Usually, this entails amber. Some famous preserved remains are of lizards and insects trapped in amber.
That was a lot of background info. It's time to answer our question. What conditions do fossils need to form? Water. Water is crucial to the process of fossilization because it transports dissolved minerals that substitute the remains, atom by atom, turning them into rocks. Almost all situations that involve fossilization involve water. Now, you may be asking yourself, how are terrestrial animals and insects fossilized if there's no water? What are fossils doing in the deserts? Deserts may have actually been bodies of water millions of years ago. Fun fact, most of the Midwest of the United States was an ocean. If there wasn't water in the form of a body of water, there was water in the ground. One of the best ways to fossilize on land is with the help of fine mud. And guess what mud has? That's right, it has water. When an organism dies in or near fine mud, it is buried. Oxygen takes a long time to reach the remains in fine mud, which is really good for fossilization.
There are 2 or 3 factors that are really bad for fossilization. Those are heat, oxygen, and sometimes scavengers. Heat melts rocks and fossils, which in turn stops the fossilization process and makes the matter essentially disappear. Oxygen is a major aid in decomposition, which is exactly what we don't want. We want the remains to remain intact for as long as possible, allowing the minerals to replace the parts or whatever process entails for its type of fossil. Preservation of remains is insanely more effective when there's no oxygen, meaning at the bottom of bodies of water that have much less oxygen and fine mud. And of course, we don't want scavengers that will eat the remains. Millions of years have passed, the fossils are formed. What now? To be discovered, they need to be brought to the surface. Erosion and weathering are two major aspects of exposing fossils. Erosion is the action of surface processes that remove soil, rock, or dissolved material from one location on the Earth's crust and then transports it to another location. Weathering is the action of the elements changing in color, texture, or composition of rock, rounding its edges, or gradually disintegrating it. These processes eat at the sedimentary rocks and expose the buried treasure.
Let's recap. Our questions were, what fosters the creation of fossils, and why don't the specimens just decompose? Some of the important things we learned were that, first of all, fossils are the remains or traces of ancient life or organisms that have been preserved by natural processes. Fossils are found in bodies of water and desert with sedimentary rock, and the fossilization process. An animal or plant dies, is buried so that no oxygen deteriorates the carcasses and no scavengers come and eat the remains. The remains are then covered in sediments over millions of years, transforming into sedimentary rock, and the imprints are either usually filled or the remains are replaced with minerals, turning into rock.
Let's talk about the first dinosaur bones to be discovered. Way back in 1676, Robert Plot, the curator of an English museum, described and drew a thigh bone that he believed belonged to a giant man. Although that fossil disappeared without a trace, the surviving illustration suggests that it may have well been a part of a megalosaurus. Later, in 1822, large teeth discovered in England by Mary Ann Mantell and her husband, Gideon, were thought to be the remains of a huge extinct iguana. It wasn't until 1841 that British scientist Richard Owen came to realize that such fossils were distinct from the teeth or bones of any living creature. The ancient animals were so different, in fact, that they deserved their own name. So Owen dubbed the group Dinosauria, which means terrible lizards.
These were all actually found in the United Kingdom. These cast fossils are from the Mesozoic era because that's when the dinosaurs lived. This means these fossils are remains from beings that lived from 262 million years ago to 66 million years ago.
What's the relevance? What do fossils even do for us?
Fossils help us decipher the history of the Earth. They can help us determine the geologic age and environment, also known as the paleoenvironment, in which they were deposited. They also help us better understand the evolution or progression of life through geologic time. We also made fossils out of clay, just because.
We'd like to give credit to our sources and our immersive program and Nicholas Fisman and Cole Stevens.
And that's all we have for you today. Thank you for watching and feel free to ask us any questions.
Thank you.
Thank you.
Thank you for watching.
Wait, no,
Hi. Do you have any questions?
Thank you. Thank you so much.
All right, I'm back. Hello, everyone. Wasn't that amazing? Thank you so much, Ella and Stella.